This is my colleague Jean-Philippe. And Marc Blanchet is not with us, but it's important to acknowledge that he started everything related to IPv6. Okay, so the first session is going to be the user perspective. We're going to tell you what is IPv6, why it's important, and how to enable it in your network and in Asterisk. And then we're going to do a small demo just to show you that we're not lying. It works. For the second session, if you stay with us, you will learn about the programmer perspective. We'll show you the new BSD sockets API for IPv6 and how we wrapped it for Asterisk in a new module called NetSoc2. Okay, so we ported Asterisk to IPv6. We also ported FreeSwitch to IPv6 2 years ago. We developed NUM, a stun and turn server, and as far as I know, it's the only server that supports IPv6 right now. We participate in IETF. We participate at CIPIT, Glucon, Astricon, and we're consultants. Okay, so the history of Asterisk and IPv6 is fairly long. We started development in 2006. It was based on the branch that was to become 1.4. And Mark presented at Astricon 2006 in Dallas. And development progressed in parallel in our own branch because it's a big change. It touches everything, and it touches the very foundation of Asterisk. So it was not easy to merge into trunk right now, and it was risky. So we developed it in parallel on our website, and we had requests from people and improving our stuff. Eventually in 2008, we updated it to the branch that was to become 1.6, hoping that we would get into trunk finally. But still, it wasn't the right time. It was still too risky. We've been keeping it in sync for a long time, and it was some amount of energy. And we brought it at CIPIT multiple times, testing interoperability with other vendors. And eventually in 2010, we finally did the sync again and got into trunk. Okay, the need for IPv6. This is the slide that we show at every single talk that we do about IPv6. And the line keeps going to the right, and the red line that you see there, that's the pool of free addresses, of free /8s in IANA's pool. It's going down, down, down. And we're almost to the point where there's no IPv6, IPv4 addresses left in IANA's pool. That's going to be June, this next June. And the green line is what's left in the RIR pool. That when the RIR don't have any more addresses, they ask IANA, and that's why it fluctuates like that. But when the IANA's pool will be empty, the green line will go down also. Yep. Closer. Okay, like this. Okay, so what happens afterwards? IPv4 will be sold out. So anybody can guess what will happen. Will there be a black market for IPv4 addresses? No one knows. Maybe, on the contrary, maybe IPv4 addresses will lose all their value because everyone will have adopted IPv6. Are we ready for what will happen? Are you ready? That's the introduction. Okay. The status right now of the migration, operating system support, we're there, no problem. It's been there since a long time ago. For equipment like routers and switches, it's mostly there. Some feature parity is still lacking. For example, if you use this esoteric feature in OSPF, maybe it's not there. There's still some catching up to do. But nothing preventing deployment. If you want IPv6 transit, you can get it, no problem. Tata NTT, Cogent, Level 3. We used to list the few ones that had IPv6 transit, but right now it's mostly everyone. For customer access at the edge, that's where it's still very lacking. There are ongoing trials. Many ISPs are doing trials. If you're with Comcast, you can get IPv6 in your home right now. There are very few full deployments. And the alternative solution for regular people at home is tunnels. And there are many solutions for that too, and it's all free. For SIP equipment, open source software is mostly there. These open source software all support IPv6. Asterisk is the last one to join this gang. Hard phones, we know that SNUM phones support IPv6. Other vendors, well, I'm going to cite the SIP 26 report. Just over half of the implementations present supported IPv6. So we're getting there. Okay, so what is IPv6? It's a new version of IP. It's completely independent of IPv4. There's no backwards compatibility. It fixes some IPv4 issues, and mainly the big issue is addressing. It gives you more addresses. So an address in IPv6 is 128 bits, whereas in IPv4 it's 32 bits. So it's not 4 times more addresses, it's infinitely more times addresses. And it adds some functionality such as mobility, but we're not going to talk about that. IPv6 addresses are written in hexadecimal with colons as separator. You can compress an address. If you have a series of zeros, you can use 2 colons. For example, here, 2001 colon db8 colon 1 colon 1 colon colon. The colon colon means a series of 0 that you insert there. And you can omit the leading zeros in each component. For example, db8, there's an implicit leading 0 there. It mostly looks like MAC addresses, but longer. In URLs, since they use colons, you need to use brackets to separate the colons in the addresses versus the colon for the port number. Even if there's no port, if you use them in a URL, you need to use brackets. So it means changing the parsing function for pretty much everything. In Asterisk code, for example, there was a lot of grepping for a colon. We had to change all that. The loopback address is colon colon 1 instead of 127.0.0.1. The link mask is fixed. That's new. In IPv4, you could use any length that you wanted. For IPv6, it's /64. You can force it, otherwise it's discouraged. There is also a unique private address space. So in IPv4, there's a private address space, 10.something or 192.168. In IPv6, there's a unique private address space. So there's an algorithm to generate a prefix for yourself that will be private, unannounced on the internet, but you can be sure that it won't conflict with anyone else. So if you grow big and acquire somebody else, or if you're connected on 2 VPNs at the same time, there's never any conflict possible. Okay, some more characteristics of IPv6. There's no NAT. There's no need for NAT. Sure, you can go ahead and put a NAT, but in practice, there will be no need. We can configure IPv6 addresses without DHCP. That's a feature that is enabled by the length of IPv6 addresses. Since we're using a /64 for a subnet prefix, we have 64 bits left to identify hosts. So we take, each host can, when a host knows the subnet prefix, it can just append its MAC address and pad with some more bits to make up 64. So that's it. The router broadcasts the prefix on the link, and each host, when it receives this packet, it just generates an address for itself. No need for DHCP. But still, DHCP exists in IPv6. You can still use it if you want to. We can have multiple addresses per interface. And they're not aliases. They're real addresses. This is a real snapshot. Actually, it's not real. I had many more. I had to strip a few of them to make it fit on the slide. Here, you can see the scope also. There's the last one at the bottom, FE80. That's the link scope address that everybody gets. If you do an ifconfig on your laptop right now, you will see it. And all these others are generated. And the first one at the top is my fixed address. It's shorter. It's easier to remember. We can have IPv6 addresses in DNS, of course, and it's a new record type. Instead of being A records, it's quad A records. And it's named that way because IPv6 addresses are 4 times as long. And there are many more features, but I'm not going to list them all. We need to talk about VoIP also. So why is it cool for VoIP? What does IPv6 enable? It's simple. There's no NAT. I've had so much trouble with NATs deploying VoIP. It's always the number one source of issues. You get audio in one direction and you know, oh shit, there's a NAT. So with IPv6, it restores end-to-end reachability between 2 hosts. So there's no NAT, no stun, no turn, no ice, no midcom, no complexity. It just works. But then you have firewalls. Okay. So there are still some issues, but the NAT issue is fixed. It's much easier to deploy. There was a case study about the VoIP IPv6 deployment in Japan, and they found important reductions in cost just because there's no NAT. And it's easy to create address plans, and you never run out of addresses. Solves many headaches. The big problem is applications. You need to change the code, port them to the new API. If you want to get IPv6 today, if you want to try it out, you can just ask from your ISP if it's available. It is sometimes. Or you can use a tunnel broker. There are many out there. They are all free. You have a regular IPv4 connection, and over that, they put IPv6 packets. And they encapsulate very easy. You get an MTU 1480, and it works. Okay, we're going to switch speakers.